This is Breaking Down Security, and I am Brian Brake. Welcome back, listener. This is Brian, Miss Berlin, and Mr. Betcher for Breaking Down Security.
Hello.
Hi.
Hey. So isn't it like Christmas today, everybody?
For you.
It's like Christmas in May. I love it.
So you got gifts.
Yes,
Free
I
gifts.
did. I melted my card today. May 1st is when all the training and the tickets and the things happen for DerbyCon. Actually, what was it? Saturday. I happened to be in the supermarket with my wife, and she was getting yogurt, and I checked my Twitter, and it's like, oh yeah, we're releasing like 100 tickets. I'm like, boom. So I bought 3 tickets for DerbyCon. And then, I was going to get some training. So I, this morning I, refreshed the page like everyone else did and hit the training. So I'm going to be with, was it Josh Schwartz, Fuzzy Knob? I'm going to do the red teaming class at DerbyCon. So that's a good thing. And then I bought my hotel, airfare, and whatever. So we're going to be at DerbyCon, and I have a ticket. At least we're going to give away 1 ticket for free for DerbyCon this year. So we're going to have to start working on our CTF.
Yes.
So that'll be a planning meeting. So.
Planning meeting.
Planning meeting.
Cool.
Yes.
Can't wait to work on it. I have a bunch of good ideas.
Yeah, me too. Mr. Betcher's got some too, I hope.
Uh-huh.
Wait, what's that? Hacks? What's Hacks? H-A-X. Oh, it's it's the DerbyCon ticket.
It took a minute.
Sorry, it's a DerbyCon sticker from last year.
It's okay. It's late over there in Seattle.
Yep. So
5 o'clock in the afternoon.
That's right. It was it was a good day. It's 7 o'clock. It's past my bedtime, 6:30. So MacGyver's off. So anyway, well, Mr. Betcher, myself, and Miss Berlin will be at DerbyCon. Whether or not we're speaking, we'll definitely be doing training. Me and Mr. Betcher, and then Miss Amanda will get a talk submitted and approved. I'm sure of it. So so we'll all be there. We'll have to do a meetup or something.
Yeah.
Yep. Anyway, we're not here to talk about DerbyCon. I'm sorry if you didn't get tickets, but if you keep listening in the coming month or two, you'll get the chance to win. So this week we are kind of building upon other podcasts that we've done. We did a show on 2FA and multi-factor auth. We did a show with Jason Garbus on software-defined perimeter. We've done a couple of shows with Paul Coggin on software-defined networking. It's apparently the end of times. Software-defined networking is the end of times. But this week, we are actually adding on to the software-defined perimeter by interviewing 2 gentlemen by the name of Evan Gilman and Doug Barth. It is Barth, right?
It is, yeah.
Ooh, yes. Challenge
That's
unlocked.
a rarity.
Hey, come on, man. Anyway, so Evan, Doug, welcome to the show.
Thank you.
Awesome.
Yeah, thanks for having us.
Yeah. So I'll start with Evan. Maybe you could introduce yourself. Tell us a little bit about where you, how you got to where you are, and what you do in InfoSec or IT.
Yeah. So as you said, my name is Evan, and I'm originally my background is network engineering in academia. So I came from higher education, working on kind of large open research networks. And found myself in an opportunity to kind of switch gears a little bit and go into more traditional like ops SRE kind of role here in San Francisco Bay Area with a company called PagerDuty. So I worked there for a number of years, and while working there, had some unique network challenges and requirements that needed to be met, and built out a lot of automation to solve some hard security problems in the face of, if you will, like cross-cloud kind of infrastructure. So PagerDuty had deployments, many different providers across open internet with like quorum-based systems operating over those links. And so there's a lot of interesting kind of challenges that arise in that sort of architecture. And so I worked on solving some of those problems there for a number of years. And that's actually where I met Doug. And now have most recently actually departed PagerDuty to focus full time on this problem that we're about to discuss today called Zero Trust.
Cool. And wait, Doug, Doug.
Yeah.
Doug, yes, Doug Barth. Sorry, I had to go back. I have the memory of a goldfish. I only picked Evan first because his name is first in the book. So and we'll get to the book. We'll talk about that in a few minutes. But Doug, tell us a little bit about yourself. How you got to where you are. Your superhero origin story.
Yeah, definitely. So I'm Doug. I am an SRE now at Stripe, working on a team that they call Delivery, which is just a very nice term for like the team that gets all the odds and ends of Stripe. So I deal a lot today with deployment systems, network architecture, security systems, a whole bunch of stuff. But my actual original background is I've been a developer my entire professional life. Started way back when at a company called Orbitz, doing Java development. And over the course of my career, went from a large company there where you had someone else managing your infrastructure to a small startup where that was all my responsibility to then PagerDuty where I was dealing with PagerDuty's infrastructure. And, just really liking leveraging my developer experience to kind of take away a lot of the pain of running infrastructure and actually kind of treat it as a large distributed system that we could do some really interesting things with.
Nice. Very nice. All right, so the reason we had you on is one of our mutual colleagues. His name is Nick G, as I affectionately call him. Emailed me and said, "Hey, these guys. He said, hey, love your show. Mr. Betcher's very nice. Maybe you should have these two guys on. They're talking about zero trust networking." I was like, "Oh, okay, cool." So, You're writing a book for O'Reilly, much like Miss Amanda did and Mr. Brotherston did for the release, and it's currently in pre-order. You can pre-order up to, I think I have just downloaded it prior to the show starting here, and the first 7 chapters looks like have been sent out. What made you guys want to write this book in the first place?
Sure. So the way this kind of happened is interesting. So when we were at PagerDuty, we're building these systems that have to run critical and sensitive data over the internet constantly. And so that kind of affected how we built the network architecture of the system. And so we did a lot of fun stuff there with configuration management systems and automation to more or less abstract away the particulars of the network and treat it as kind of like a virtualized network, but avoiding running just an overlay network on it. Mm-hmm. And so we built all that tech. We thought it was neat. We started talking at industry conferences like O'Reilly's Velocity Conference, DevOps Days, things like that, and kind of built this model of how do you build a system that doesn't trust the network. And what we found is when we would give these talks, people would say, "Oh, this is really neat. Where do I learn more about it?" And we'd go, "Well, you have to come talk to me and we'll, I'll tell you what I know right now." But there was nothing that you could just concretely point to and be like, "Here's how you build a network where you don't have traditional perimeter systems."
Sure.
And so that got a discussion started with O'Reilly on maybe there's an opportunity here to capture this idea, because as we learned more about it, a lot of companies are actually doing this, but they haven't really been completely public and obvious in the way they're doing it. I'd say the one company that has done that is Google, and they've gotten a lot of press and interest, but there are other companies out there that are doing that. So That's how we got started on it.
Very cool.
So did you build that network from scratch at PagerDuty?
Yeah, pretty much. Prior to the existence of that kind of a network at PagerDuty, everything was kind of wired up by hand on a case-by-case basis. The infrastructure is still very small, and we had this very probably one of the largest drivers is that we had this disparate interface for security controls. Some providers, like AWS, provide a security group. Some didn't have any kind of analog to that sort of thing. So we were kind of forced to come up with, a common abstraction for those things and a software way to implement the enforcement policies, which we would prefer to enforce regardless of what provider the compute resource was in. So a lot of the stuff was all built in-house and custom grown and just kind of evolved over time. Through our experiences operating it. And there is, which we can talk about later, a bit of an evolution story on kind of how that network evolved and came to kind of grow its chops, so to speak.
Okay. So
at the time, did you know Google was doing it when you started?
I don't think Google was public until 2014 when they did their first
Okay.
Beyond Core paper. But it was kind of neat when that came out because, some of the ideas that we were sitting there thinking about, like how do you start from the assumption that someone malicious is on your network and work your way backwards towards security was a lot of what Google was talking about with their own security or network security architecture.
Yeah. So we had Jason Garbus on, who was on the steering committee for the Cloud Security Alliance's standards for software-defined perimeter. How does zero trust networking and software-defined perimeter how are they the same and how are they different? Or are they just different implementations of the same thing, or is it just fancy marketing calling it zero trust?
Sure. So I'll take that one. I think that, Doug and I have been closely following the SDP, software-defined perimeter standard set for quite some time now. We came across it in early research and doing our book, and we've been following the development of it, and we really like the work that's going on there. Our viewpoint of, zero trust versus SDP, so to speak, is that, zero trust is a model. It's an architectural model. It's a set of philosophies by which you build a system against. I would label SDP as, a software implementation of a facet of the zero trust architecture. So I believe that SDP is a zero trust technology. I think that, it solves probably some of the largest problems that we have that we can throw zero trust at today, which is the client-facing systems.
Mm-hmm.
But there's a whole other story for systems living inside the data center, across data center boundaries and things like that. So I think we look at SDP as, a definite component of zero trust and something which implements the zero trust model, but is kind of, a slice of the pie in the larger picture.
Mm-hmm. Okay. So how does a mature company who already have their own traditional network just decide tomorrow morning, hey, let's do zero trust? Because obviously that's not going to happen. And in many cases, it may be impossible. You guys mentioned, you mentioned implementing this at PagerDuty, I believe, which is a fairly small company, very not complicated network. How would a company say, I don't know, with a couple thousand people who've been around for about 10 years, already got an established network, how do they use this instead of, the traditional like VPN or whatever that they use?
Sure. So I think what's kind of interesting about that is like, if you think about Google as like the company that's leading the way here, they obviously have a giant network, right? Mm. And so they talked about how they transitioned to that. And what's kind of shocking about their Beyond Core paper is like how just kind of straightforward it is. You end up, logging all your traffic, you start categorizing it, you do simulations, you just try to figure out, well, how do I like slowly gain some confidence that this, all this policy and security controls that I want to put in place aren't actually going to start breaking things. Mm-hmm. I would say most companies, or a company that wanted to start transitioning away from a perimeter model to a zero trust model, probably try to do it on like kind of their most core data asset, and start in the small and build out in their network. It really kind of depends on what you're worried about. Like Google, somewhat interestingly, like they started from what might be a harder problem, which is I have all these remote endpoints that I don't even trust that their access to the VPN is enough for me to say with certainty that there's no one malicious in there. Mm-hmm. And so they took on like that chance, but they still put like a separation, right? They still have an access proxy that is receiving client connections, doing authorization and really deep checks, and then proxying it through to a backend network, which probably looks more traditional than the internet facing side.
Yeah.
So tell us what it is in a nutshell.
I think Doug's favorite way to describe it is simply you build systems with the assumption that the host in your infrastructure next to you is already owned and your network is already owned. And how do you go about constructing security systems and distributed systems in a way which takes those considerations in and kind of limits the impact and damage of an attacker on any given node in the infrastructure, right? And particularly like with network capabilities as well. Mm-hmm. So I think kind of the crux of it is, most people when you build an infrastructure, you start with a perimeter and you lay this line down and you say, okay, everything behind this thing is kind of safe. And then you build a bunch of value back there, a bunch of services and other things. And then eventually you kind of circle back around and say like, oh, wait, now like you have this major lateral movement problem and all these other things, right? So the zero trust model kind of says, you know what, like time and time again, we have seen that when you say this section of the network is trusted, leads to very unhealthy behavior and very poor security systems design. So rather than that, we just put the basis down and say, look, you don't trust the network at all. And when you design the systems, you design it such that there is no such thing as behind the firewall or anything like that. The hosts need to be instrumented with identity. The endpoints that you're communicating should directly authenticate each other and authorize each other. And a lot of things like that. So it's removing kind of a lot of these security functionalities from the network, and there's no more such thing as trust interface and untrust interface, so to speak. Instead, you rely on just rigorous identity authentication and authorization through the use of like automation and other things.
Okay, so it's largely a flat network then, right? If you're telling me that no one trusts anyone, then all the nodes are pretty much the same and they all have their own rule set applied to them, right?
Absolutely, yeah. And it depends on how you use the word flat, So I'm coming from a network background, and when I hear flat network, I think of like, giant layer 2, broadcast domains, right? And the kind of the nice thing about zero trust is that it doesn't really rely on any kind of underlying network architecture. If the endpoints can reach each other, then they can do cryptographic negotiation through that reachability and also protect those links. So it's not necessarily, a large flat layer 2 network. It's more kind of like lifting the topological concerns out of the network and saying, I'm a host, you're a host, I can send you packets, I can receive your packets. How can I ensure that you are the person that, in fact, that I think that you are, and that the request you're trying to make is actually authorized?
Yeah. So this model seems to run kind of counter to how we do things normally these days, where we don't trust the client coming in, where now it's like you're not trusting the server you're connecting to. And in the other cases, the server isn't trusting the client either in the more traditional sense, but it's like nobody's trusting anybody, which is why we're having zero trust. But how do you build the trust?
We have zero trust now without the design of the actual.
Yeah. I mean, as security people, we don't trust the clients who are coming in because they're not patching their stuff. Most companies don't have an MDM solution, for mobile devices. How do you build trust in a no trust network?
I think there's two things. The way I think about it is that there's the enforcement piece, right? Should I trust a client coming in? But there's also like the heavy monitoring of that internal network. So even though we're talking about like, okay, these two endpoints can like cryptographically start communicating with each other in a way that we think is pretty trusted. A zero trust network like BeyondCorp will still like analyze that traffic for anomalies and try to figure out if someone is leveraging credentials to do something malicious in the network.
Mm-hmm.
So you end up almost with like kind of three people watching each other, making sure they're doing the right thing.
Okay.
Yeah. And to add to that a little bit, it's kind of like, the things which are, quote, trusted, like your servers or your users or whatever it is, right? You don't install total trust in them, you install some amount of trust, right? So I pretty much trust that you are an authentic user, and I pretty much trust that this is an authentic device. And the authorization comes from a union of those things. Considering the trust in aggregate and saying, okay, well, this is like what I'm pretty sure is an authorized user coming from what I am pretty sure is an authorized device, accessing a resource which I am pretty sure is one that they would normally access. Therefore, we can say with a fairly high degree of confidence, this is probably an authorized action.
So a bunch of pretty sures equal okay.
It's essentially the same as like multi-factor authentication if you think about it. It's like saying, look, you have the password and you have this token and maybe you have another key. Those things together give me a boosted degree of confidence to say, all right, this is probably what I think it actually is, right?
Yeah.
And zero trust networks take that into account. And one of the cornerstones is that you should never authorize only a device or only a user or only an application. It should be those things in conjunction together.
Okay.
What do you use as this third-party tool, right? To say, X wants to communicate with Y. Mm-hmm. Okay, I'll let them because I think that's allowed. And it doesn't look like it's suspicious in any way, and probabilistically it looks okay, right?
Yep.
What's there in the middle?
Yep. So I think right now the fact is that in these types of networks, it's custom software, and that's something that needs to improve in order for this model to go out into the industry more. But then somewhere in the system exists like what we would call like a policy engine that is taking in requests that it needs to authorize, checking them against sources of truth that it's scraped out of either the network activity or like say scans of a device or a user database, and just making that determination. And then kind of the neat thing that you see in these types of networks is there's often like kind of this split between who defines policy. So you might say like individual services, let's say your company's running like a wiki and it wants to offer it to mobile users. You might let the team that actually runs the wiki set some portion of the policy, but you might also have like an infrastructure group that's setting like base rules for policy. And it's like the union of those two policies defines whether or not someone gets access. And that policy engine is responsible for like kind of churning through all that and making the final determination at that point in time. Do I allow this access? That may be different later based on how that user behaves.
So, and what did you build that policy engine with in the past?
So, sorry, go ahead.
Did you write a Java app? I know, Doug, you said you were a Java developer.
I used to be a Java developer. Now I don't do Java anymore.
He got better.
Yeah. You were.
I was, yes.
So this is kind of, touching on an interesting point is that, there's lots of different stages of evolution or maturity of a zero trust network. You can have some that are relatively primitive, and you can have some which are considered advanced. The key kind of goal of a zero trust network is to distrust the network or remove whatever trust exists in the network already, whether it be by trusting a particular source IP address or what have you. So as long as you meet those requirements, that's kind of the model, right? And so you can meet those requirements in kind of a bare bones way. And once you meet that, that's kind of like the first step or foray into adopting the model. And then the things can evolve, and there are all these interesting attachment points and other ways that you can extend those enforcement components. So the networks that Doug and I worked on at PagerDuty, the way that this was done is that the policy was encoded into configuration management systems. And configuration management systems also performed what we call device inventory responsibility. So it was aware, our configuration management service is aware of what hosts are in the infrastructure, what their roles are, what their responsibilities are, is also aware of what kind of policies might be attached to those particular roles. Role X is allowed to be accessed by role Y on port A, B, or C, or whatever it is. And configuration management is smart enough to go out there, do those queries, figure out what's allowed, and wire things up dynamically. So as the topology changed, we would see those policies get pushed out and changed in the actual kind of enforcement layers, so to speak. And that just could be basic IP tables or IP set configuration and things like that. So at PagerDuty, that's how we solved that particular problem. And as the zero trust network matures, and even at PagerDuty, we started scooping pieces of those functionalities out into dedicated services and out of configuration management. And then you start to see dedicated services which can take in kind of generalized policy about workloads and then crunch them against real-time updates from these various inventory databases. So as you can see, it can go from kind of very basic, just really easy, hey, we wrote it over the weekend in Chef, all the way up to a myriad of dedicated backend services which power these dynamic authorization decisions.
I think the key thing to get comfortable with there is the idea that your network is not going to be defined by you configuring individual, say like subnets or port ranges, right? It's going to be captured what I like to call symbolically. So you're saying this app or this client is talking to this app on this port, and here's the meaning behind this, and then you're just going to let the machinery actually reprogram the network.
All right, so let's say I have a traditional application where I have a web front end, I have an application middle layer, and I have a database back end, and I'm processing e-commerce stuff. All of a sudden, my CIO comes in and says, hey, I saw this in CIO Monthly called Zero Trust Networks. Let's do that. How would somebody take a traditional 3-layer application with proper segmentation, and maybe you're doing a little PCI going on here, and just all of a sudden turn it into a Zero Trust network?
Right.
You want me to take it?
Yeah, you go first.
It's a hard question, is what that means. We mentioned earlier, Doug and I kind of built this stuff from scratch. Most of the people that we talked to today who have built networks like this have built from scratch. We all are kind of surprised to run into each other when we say, hey, we've been building stuff kind of the same way. And then you talk about, the ways you've done it, but there is no common solution, unfortunately. The building blocks are common, right? You can use IPsec is there. You can use TLS, right? You can use IP tables. You can use Berkeley Packet Filter. You can use Windows Firewall, whatever. Like those fundamental building blocks are there. So what's really required is kind of the glue between them, and really just the automation glue. I think one of the largest requirements is that you have to have some idea of what's running. Which means you need a device inventory, and you need a database which is documenting the workloads and the policies attached to that. So that's probably the first step. If you have an infrastructure in which there is no centralized source of truth for what is running, start there for sure. And then the next step I would say is like we did at PagerDuty. We kind of took it one step at a time when we started building this stuff into admittedly very heavyweight configuration automation. But that kind of gets your toe in the water. And once you kind of have that going, you can see the value and then start dedicating time to scooping those things out and evolving them into larger things. But again, I do think it currently, unfortunately, it is kind of largely roll your own.
Yeah.
So Evan was so brave to do that first. The thought that's running through my mind is I work with someone who says, in our security team, who says his job is basically to go around and say the word threat model a lot.
Yeah.
And I would say that's where you start, right? Is what are you most worried about, and what are the assets people are going after, and then kind of work your way backwards on what's the first improvement I can do to the system. Yeah. I mean, in a lot of ways, this isn't it's not magic sauce, right? This is just well applied security practices. Under the assumption that someone malicious is sitting there on the network. Sure.
So, Miss Amanda, you've been fairly quiet. Do you have any thoughts or questions? I know this is
a lot. Yeah.
Please don't hesitate to jump in. We're not,
Well, I was choking there for a minute. I had to mute. That's what happens when you inhale what you're drinking.
Yeah, especially if it's bubbly and alcoholic.
Right. Yeah.
Yes.
That too. The one question I had was, how have you seen anybody do this when you have BYOD? Does that go in? You have to know what you're running and what devices you have. And I know a lot of people struggle a lot with not only asset management, but knowing what software is even running on their network. I didn't know if BYOD changed that at all.
Yeah, I think so my current employer lets us run our own devices, and kind of the interesting thing as they build out this type of capability is depending on the device, you get different levels of access. So especially on mobile devices, Apple currently has probably the best platform for securing that device. And so we're very quickly saying you have to have an Apple device in order to be on the network. And even then you still have some a reduced amount of access relative to say someone's actual laptop. Which is kind of the thing that's one of the things I find interesting. So we have an entire chapter called network agents, and that is our attempt at a term that captures this idea of what do you call the union of someone's device and user and application, and we're calling it an agent to try to echo user agent. But that's kind of a key idea, right? Is you are not authorizing a user or a device, you are authorizing the network agent, which is all of those things put together at a particular point in time, and that's what you're making a policy decision against.
Okay.
Because I'd imagine at a certain point you'd have to do that. Say you need to have Apple or something. Otherwise, you're going to be reconfiguring that homegrown, system daily, to deal with everything.
Yep. Reconfiguring in what way are you thinking?
Just if it's a different kind of device. I mean, I'm assuming they all have a different type of, if they're, a different OS is going to have different, capabilities or whatever you might have to take into consideration when they're connecting to whatever app or
One of the trends that we've been seeing is that in client-facing zero trust systems, so systems which are providing a service to users in an office or in the field or otherwise, tend to heavily skew their interaction towards the browser, towards like browser-delivered apps. And one of the big reasons for that is that you can configure the browser usually relatively trivially for mutual TLS. So the problem is reduced to, how strong is the crypto store on whatever device you've brought, and how can I load a key into it, and how can I configure your browser to speak mutual TLS, and because that gives you kind of the device authentication, so to speak, and once they hit their web resource, you drag them through your regular IDP and multi-factor authentication, and you kind of get all those things for free, essentially that device authentication underneath. Okay. So to alleviate that burden of like myriad of devices and different capabilities, most of the client-facing stuff is, we see at least, typically delivered through the browser.
Which is happening a lot lately anyways.
Yeah.
Everything's a web app now.
Yeah. So when you're mentioning your third party thing, like Mr. Betcher asked, you're basically relying on the CA model, right? Where a third party determines who gets trusted between the client and the server and how much trust each party gets. So, I mean, can you have it where the client is completely trusted, but the server is not, and vice versa? Or is it like an SSL connection where the highest possible trust is negotiated between the two, and that may not be like you get the keys to the kingdom. You may get like, low level user access or something.
Okay. I think that the authorization is made largely against the requester. It is usually an ingressing the service that is the backend service, so to speak, at which the authorization is done. It's usually done closer to the thing of which you're trying to protect and not the requester side.
Right.
So oftentimes when that relationship comes in, it's less so much like, hey, is it going to the right resource, so much as it is, hey, what resource are you requesting? I know how to forward and handle that, but you must be authorized first.
Okay.
But it is definitely, everything has to be mutually authenticated, because there's definitely kind of this, well, if I don't authenticate the server, how do I know I'm not being man in the middle from Starbucks? Mm-hmm. And if I don't authenticate the client, there are similar concerns there.
Sure. So I guess with zero trust networking, your microservices become very important. Using containers in this case, that makes it a lot easier to manage these things, because microservices only open certain ports, only allow certain protocols. So let's say you're a Google, for instance. Mm-hmm. You must have hundreds of microservices or something running in the background that have to be load balanced. How does zero trust networking work with, say, a load balancer or a WAF or something that helps protect these devices? I mean, if you're coming into a website and you're just, I'm just Joe average user visiting Google, that gives me what access? I've got no certificate. I've got no authorization. I'm just a guy. How does that work with regard to load balancers, with WAFs, with, SSL accelerators, those kinds of things, like regular infrastructure?
Sure. So I think actually like the continuing shift towards like containerized applications is like kind of the sweet spot for this network model. Mm-hmm. And the reason it's the sweet spot is because those container schedulers have a source of truth that you can reference and start like rolling out credentials between two communicating systems. So like in your load balancer example, what you're probably going to need is you're going to need either a load balancer that has like an API that you could have automation reconfigure, or has some like plug-in point where you can actually put a check to make sure that you are load balancing to the right backend system. Mm.
So either one of those UPnP is getting sexy again, is what you're trying to say.
So that's the interesting question, right? It's like this, you definitely don't want to go down the UPnP route. So how do you build like trust in the systems that want to expose a port to the internet without like just letting them go hog wild? I think that's an interesting question. Like kind of the way I would try to tackle this, and I think a lot of companies do this, is they try to tackle it from like a human process perspective and less so from like a technology perspective.
Yeah.
So you might want to capture that this service wants to expose a port. close to the service like definition, but you certainly don't want to let that like deployment of the service just unilaterally open up a port.
Yeah.
Right? So you probably send it by security, they approve it, and then it goes through some other like system that they have access to actually go make the change on behalf of the service. But the key difference here is like you have really great traceability that can be like automated and automatically audited and make sure that it doesn't fall out of sync.
But so to add on that just a little bit, oftentimes there's we talk about client facing zero trust networks, what they look like. We talk about data center zero trust networks, what they look like, and they're different applications certainly, and as a result the implementation is oftentimes looks different, and there can be a lot of confusion. And how does the loop look like when you have this data flow which is coming from the client and flowing into the data center? Like, how does it cross those boundaries, and how do you maintain that kind of secure relationship as the packets come from Starbucks into your data center, across your routers, and into backup services? The way that I like to look at that is, you consider the load balancer, which is front-ending your service, as kind of part of the service. It is the entry point. And between the load balancer and the client is one secure relationship, and between the load balancer and the backend service is a different secure relationship. So clients will terminate on the load balancer, and the load balancer will make its own authorization decisions through, as Doug said, either inbound configuration or outbound calls dynamically. And then separately, there's a relationship which exists between the load balancer and the services it's forwarding to. And you can do behavioral analytics on both of those sides, right? Is the load balancer acting kind of strange? Is the user acting kind of strange? But it's actually a much more natural marriage than you would think that it is. It's simply, if you just bend tilt your head in the right way and say, well, the load balancer is really kind of part of my service, and the load balancer looking forward to the clients is that client-facing bit, but looking back from the load balancer is kind of that server, that back-end part, right? Does that make sense?
Yeah. The thing that gets me is that you mentioned the client to the load balancer. So you got A to B. You got the load balancer to the server, which is B to C. But A to C doesn't necessarily equal a trust relationship. So you have to deal with that load balancer being the man in the middle, which could be a point of weakness and point of attack to screw both ends of the equation in this case, right?
So usually in these kinds of deployments, the load balancer will do its authorizations at layer 7. So that thing will be like an HTTP load balancer or something of the like, and speak application protocol. And the authorizations that go into the zero trust network as a result of that are request centric. Right? From the load balancer back to the server, you can say, well, we've already done like a fair degree of authorization of this request itself as it entered the load balancer. And the relationship that you examine and trust between the load balancer and the backend service is more like, is this a trusted load balancer? Do I trust it to inject the right headers? Are the access patterns normal looking? Those kinds of things. So it does seem kind of like a way that something might be able to sneak in, but the reality is that unless the load balancer is owned, you won't be able to inject. And if the load balancer is owned, then the behavioral characteristics between the load balancer and the backend services is something that might be able to be detected.
Okay. So I'm a company, and I'm coming in and I'm employing Amanda's company as an MSSP. She's like, okay, great, let's look at your architecture. And we're like, oh yeah, we're doing zero trust networking.
If I had a company that was that advanced with their asset management and knowing what data is on their network, I don't know that I would really have that much of a job to do.
Well, so that's my question. MSSPs use things like IDSs and IPSs to monitor network traffic. How does a zero trust network allow you to monitor the network traffic unless you're actually doing it on the host itself, which, one, you're running into resource issues, especially if using Amazon instances. You don't want every instance to be running a local IPS or IDS. How do you monitor the traffic between that? Are you using some kind? And you mentioned setting up secure connections between that. That means SSL decryption. So you're going to have to decrypt the SSL between that. I'm looking at performance issues all over the place here with this.
Yep. You want me to take it?
Yeah, sure.
Okay. The short of it is absolutely you're right. And IPS IDS is going to take a hit. And that's kind of the point. Like you are protecting against things like IDS and IPS. Maybe in this case you want that thing to be there, but those are exactly the kinds of intruders that you're looking to mitigate. So yeah, you're going to take a hit, and I think that the right approach in this case is. It's hard to really say because I haven't worked on it myself, but I've spoken to people who have worked on these kinds of systems. Mm-hmm. And the general accepted approach is you do like S-flow instrumentation throughout the network, and then you do anomaly detection on the flow results. And you basically try to do your best attempt at correlating these flows and say, well, this flow is from this service to this service, this service to this service. What's the connection rate? What's the volume? What's this? What's that? And then anomalies that occur within that thing, you can then go and say, okay, well, this is something that we didn't expect. But also, I think that the need for IDS, IPS, like embedded in line in the network, is also quite a bit reduced because there's no longer like, oh, that thing that you didn't expect is squeaking out. Because if you didn't expect it, there's not going to be a policy for it. And it's not going to get routed anywhere anyways. Mm-hmm. So it's more kind of like, hey, we know everything that is there we actually expect. And it's more kind of vague properties of those connections, like I said, connection rate and throughput, things like that you might be able to pick up on. But your things like IDS and IPS are certainly a lot more limited in this architecture because you lose all that deep packet inspection and things that you might be accustomed to in the traditional model.
Yeah.
Does that make sense?
No, that makes perfect sense. The only other thought I was asking about, I'm learning how to do Docker and those things, and I found this interesting idea that when you send up a bunch of containers, you don't even have to have an IP address necessarily or a networking like a subnet. You can call it network Bob, and everything can be connected to network Bob or network Alice, and that really doesn't work well for like IPv4 based stuff. I mean, there's an IP address, yes, but network Bob is different than 192.168.0.1 or whatever like that. Is there some kind of network translation that goes on, because I'm coming from an outside network with an IP address. Where does the network translation occur if you're using a bunch of containers with network Alice trying to get into that? Where at what point does that happen on a zero trust network?
So I think like a zero trust network is largely aimed to avoid those kinds of complexities. Well, yeah. What we want is, Alice should talk to Bob. You shouldn't have to know what freaking network, or you shouldn't have to know any of those things, right? You should be able to write a policy that says Alice can talk to Bob, and here's how they can do it, and that's the end of the story, right? And that's kind of the model that we're driving towards. We want things to be able to work without having to understand what the underlying network topology is, without worrying about if there's NAT in between these instances or not, right? What the access should really come down to is cryptographic relationships.
Sure.
And so you root cryptographic identity in the device, you root cryptographic identity into the application, and the packets when they come in, they're if you do have any policy which is like only from this IP address, it's very small and fleeting. You really don't rely on that as your primary mechanism. Mm-hmm. What you rely on is was this packet signed by an entity which is authorized to access me in this way? Sure. Was it signed by my CA if you're using X509 or things like that? So that is a big deal, and particularly me as a network engineer, there are lots of nasty complexities that come in network architecture and topology. And the last thing you want to do as an application owner is deal with those things or have to even understand them, So I think that's one of the main advantages of zero trust networks is that, look, like we understand those complexities exist. You should not have to understand them. What you know is that thing over there should be talking to me, and I can tell you a little bit about that thing and make the rest of it work. And that's where that all that fancy automation comes into play.
And I think, like, to put this in like concrete terms, right? So this is something that Evan and I did, right? When we were constructing our network and actually like building enforcement systems, we had a system where you had the exact same policy if a network that's behind one layer of NAT is talking to a network without NAT, and same policy for NATed network to another NATed network. And the automation is able to just interrogate how those relationships are going to route and configure it the right way. Yeah. And that's like the value of that, right? Like because you're not defining your policy in terms of implementation details, you can reuse it in a lot of different ways and capture some of this complexity elsewhere where it's best dealt with and not like down in the weeds of defining policy.
Okay.
Can you implement this with let's say all you get to have is a pfSense router? I mean, is that possible?
I don't think so. It's very hard to envision this being effectively implemented without endpoint instrumentation.
Which is why you mentioned IP tables on the endpoint, right?
Yeah, okay. Exactly. And that's kind of the place where you start. It doesn't mean that you can't have PFSense in your network. You can have your PFSense in your network so long as it's plugged into this automation framework and updates automatically. So it's kind of, you want to start on the host implementation and the host enforcement, because that's where you're going to inject identity. That's where all these other things are going to come. As soon as you start putting the enforcement further away from the thing you're trying to protect, that's where you have room for lateral movement and other things to squeeze in. So Zero Trust Network Advocates started exactly the thing you're protecting, that host that is serving that protected resource, instrument that. And then once that's instrumented, you can start moving out further into the net.
So you're setting this up, and this is a grand project of your C-level folks. How do you transition properly? Because obviously there's going to be some method by which you have like a couple of hosts that you're going to be connecting to, and you're slowly going to be transferring everything over to the Zero Trust model. How do you do like crypto negotiations? How do you push out the certificates needed to do this? In our talk with Jason Garbus a couple of weeks ago, he mentioned that software-defined perimeter uses like port knocking type functions to send the token in this case. Mm-hmm. How do you get all that implemented and then still have your traditional network? I mean, are you running everything over SSL tunnels or HTTPS tunnels to be able to do the initial, and then as you're moving away from that, and you go, okay, this week the mail server is going to be sitting in its own little island, and then next week it's going to be, the file servers and such. And how do you isolate that in an environment? I don't want my file server being accessible necessarily outside of the network. I mean, are there any additional protections you can put in just, to keep China from banging on my file server?
Sure. I mean, I think the key things you need to get started is going to be some definition somewhere of who should be communicating with each other. And so you need to start building up that database. Mm-hmm. And if it's like a brownfield network, that might just be a whole lot of like network monitoring to try to discover flows and categorizing them and tying them back to service. I think the other interesting thing, we didn't talk about it before, but like the CA aspect here, a lot of companies end up standing up their own private CA. Okay. And they use that instead of a public CA. And it's simply because they want to have like very tight controls around who can actually create short-lived credentials. Mm-hmm.
One of the keys, key points that we try to hit in the Zero Trust Network is to provide the security as an infrastructure layer. So we very much look to remove all the security consciousness, necessarily, not to the detriment of the application, but for instance, like the application shouldn't have to worry about loading a TLS library and how to configure it. Right. Especially in microservices, as you mentioned earlier, this can get very messy, especially with lots of teams and lots of services, different languages, which ones implement how, TLS this way, that way. What is the right configuration? How do you manage all those things? Yep. So one of the key design aspects is, the application should not have to worry about that thing. Right? That should be offloaded as an infrastructure concern, where we can give predictable performance characteristics and predictable failure modes. Is a distinct advantage. So how I actually do that, and kind of like most of the questions in Zero Trust comes back to automation. If you want to use TLS in the data center to do this, you need to wire all those relationships up and inject the certs and do all this stuff. Lyft's Envoy attempts to do some of that stuff for you automatically, and it's an attractive solution. However, it's TCP only as TLS. Doug and I went down the path of using IPsec to build kind of a host-to-host mesh network, if you will, that was opportunistic, which would turn up whenever a connection was requested. And the advantage of this is that the cryptographic relationship exists at layer 3. So no matter what protocol you're running, it's going to go over there, and you can carve the kernel policy in a way that it says, look, you do not emit a packet which is not encrypted. you're either speaking IKE or you're sending a IPsec packet. That's it. So this is a very attractive way to kind of deploy the security underneath the running applications and brownfield scenario, right? The way that we did it is IPsec has a few different modes that it can run in. One is none. One is like, I can't remember the name. What was it? Opportunistic or something.
Aggressive.
Like yeah, and then one is required. I think it was like there's one where it's like you will not try to negotiate. You will try to negotiate, but if you don't successfully negotiate, you fall back to plain text. And you will try to negotiate, and if you fail, then you fail, and nothing goes. And the way that we rolled it out was we said, we'll start over here with a service, and you ratchet up those things to say like, okay, rather than none, we'll say like opportunistic, right? And then you ratchet up as neighbor to say opportunistic, and then you form that relationship. And then you kind of slowly roll it out across the infrastructure in a way that doesn't disrupt the flow that exists today, but also can kind of capture and scoop up all that traffic that would have been pretty disruptive to tweak otherwise. So, yeah, I think that might be what you're asking. Yeah.
So with this new network, are there any requirements like, I'm a government agency and I run XP? Is XP, could you run a zero trust network on an old 2.4 kernel or a Windows XP box? Is that even possible?
I would say you could probably let it join the network, but it would have very little trust in the network, and so probably wouldn't get access to very sensitive resources.
Well, there's always that one box out there that does the thing that we don't want it to break, and it runs Windows XP Service Pack 0, and we need it to not, do that.
I mean, these things are like we said, there's not really any off-the-shelf solution. So how much trust you grant in any particular thing is largely your own call.
Right.
If you want to put an exception in there, that's your prerogative. I can say that XP does speak IPsec and can speak TLS2. That's the nice thing about using these mature protocols is that they're very widely implemented. One of the things that Doug and I found out, neither Doug or I are Windows experts, but one of the interesting things that we found in writing the book is that the Microsoft platform at large is actually pretty well positioned to implement zero trust because of the group policy and Active Directory controls.
Sure.
And Windows comes with IPsec configuration points for group policy. So you can, push these kinds of policies out in a way, and then they come with the, domain joined hosts have certificates and everything. So they're actually fairly well positioned to roll this out without a whole lot of overhead. I just can't say that I've done it, but they do look, like promising.
Yeah. Okay. So I have a software defined network, and I'm trying to connect to another company's software defined network. If you guys don't have the same requirements and it's been balkanized, you roll your own, they roll their own, what happens?
So I think this really depends on the access policy of organization A or B. When you talk about client access, what you're authenticating is you're authenticating the client device and the user. The client device, if it's backed by X509, trust can be chained. So you have an opportunity to do federation through like regular CA trust, where you can say, hey, clients from organization X should be able to access my thing. I will interrogate their client device the same way as I do mine, except I will also allow them to have a cert which is signed by organization, whatever. Okay. And then the same kind of IDP relationships too. You can drag them through whatever identity provider they use in that company.
Well, I was just wondering because I know the Jason and them are trying to set some kind of base standard. Obviously there's going to be add-ons and stuff, but as long as you're following a baseline, then everybody should be able to contact one another. We're not talking like crazy, balkanized, where everybody's talking a different language.
Need to talk to Bizarro Bob at the other company and work something out, right?
Yeah, I think honestly, there's that's where a lot of opportunity is, and one of the things we try to highlight in the book is that this is all very new, right? We don't have all the answers, but we can certainly point people and say look, if someone could get a standard here or build an open source project that builds on these ideas and gets people excited, that's a great opportunity to have some real impact in the industry.
If only I knew a couple of guys who knew this stuff and I could start a company and make $1 bazillion.
Yeah, Doug.
Well, Evan, you said you do this full time. How does that work?
Well, that's a good question. Up till now, it's really just been pushing the book out. I think we mentioned earlier that today is kind of, we've turned over the majority of the text. So I'm trying to focus my time. My mission in life really right now is like, hey, I think this is really right. I'd like to see the world use it. What are the barriers to entry? Clearly, one of them is, well, it takes a long time to build and it's hard and you need smart people to do it.
Yeah.
So, writing the book was the first step in trying to kind of espouse this thing and get it out there and see some adoption. We're going to do, a book launch. We're going to do some conference talks. We're going to do some stuff like that.
Cool.
But, if the needle doesn't move as much as we think it will, maybe we work on some open source software, some reference implementations, and some guidance to people who want to get their hands dirty. We can maybe provide some code. And so we're still trying to kind of work out that future right now. Please, if anyone is interested in hacking on some code, just feel free to reach out to us. I'm happy to hear from you.
I'm still thinking about the PF Sense thing. Like if you have layers and zero east-west movement, right? But everything has to go through the router and no single node can talk directly to the other node. Because they have their own firewalls on board. I think that could work, but I'd have to read the book first to see exactly what you guys are defining as a zero trust network. And
I would say that it could work like that. And one of the first people to kind of espouse this architecture is this Forrester guy named John Kinderfog, and he originally posted kind of a reference architecture which included something similar to what you're talking about, where you would still have the centralized firewall, however, very, very tight relationship between that device and the endpoints it is protecting. Maybe even like a direct connection, and then just like unilateral policy enforcement through that device. So that those architectures have been spoken about, and I think that in some ways you might be able to achieve the architecture through that kind of model. Though, Doug and I have discussed this at some point, and it's almost like, man, it's like, wouldn't it be cool if there was a little puck that I could just plug into my RJ45 jack that came with a crypto identity that I could tie in my device inventory and say, I just plugged this thing into, asset X, right?
CA on a stick.
Yeah, exactly.
Yeah.
And it's very similar to the YubiKeys that people are deploying at multiple points.
Yeah, USB licenses for Pro Tools or whatever just comes in a USB key. So
yeah, and it's like a RJ45 sheath that just implements all the crypto algorithms and does the thing, right? So but that is kind of the way we're thinking, right? And certainly it might be able to be done given the right interswitch architecture and things like that.
What language are you guys using there? One of you said you're a reformed Java user or dev. So what are you using now? Like Python or
So I've
Ruby?
done most of my development in Ruby for quite the past few years. I've been dabbling a little bit in Go. If I were to write something zero trust, I probably would look at something like Rust. It seems to be the thing that people are interested in lately because of just the type safety guarantees, and therefore you have fewer chances for kind of obvious bugs.
Sure.
When I left PagerDuty a few months ago, and I left, we were writing in Ruby and Golang for zero trust purposes.
Right.
We were writing in Golang where required and where things were needed to be more mature, and writing in Ruby for fast prototyping of components that we just wanted to kind of get out there and see how they worked. But yeah, I think it's largely open. It's whatever works for you, whatever interfaces you need to consume in order to get that enforcement job done.
Do y'all have a GitHub or anything? Because we can put it in the show notes if you want people to poke around with it.
Actually, that's all of the stuff I was working on that unfortunately has not been released.
Probably all IP.
Yeah. Unfortunately.
All right. Miss Amanda, Mr. Betcher, I have one more question, but I've been hogging the conversation. So do either of you have any more questions before I ask my last question?
No, I'm good.
I'm just looking up Rust.
Is it? Oh, my God.
What? It says it's blazingly fast.
Well, it has to be blazingly fast. I'd imagine you'd have latency issues if you didn't, trying to, run it through, if you're running Perl or something, which is god awful slow. So, all right, my last question is, because this is kind of an InfoSec podcast, I don't know how you guys do with your security side, but if I was a pen tester, what would be the attack surface that I would look at first if I'm poking around on your zero trust network? Because it seems to me owning the client would be the best way to do it, because they got all the keys over there, they got all the tokens. Depending on how you do authentication, if you're using passwords, which, winter 2017 is probably what I'm using for my password, I have now access to your entire network.
The CA, I think. You go after the CA.
CA seems like a very important threat. Something to protect.
I mean, there's, endpoints are attractive, CA is attractive, CI/CD systems are super attractive for someone that's trying to attack a network.
CIC?
CI/CD, like continuous integration, like a Jenkins build server or something.
Right.
That's one that people are often very sensitive about.
Mm-hmm.
It's just the opportunity for remote code execution via getting into that pipeline.
Yeah,
deployment services. Yeah. I think one of the big things that gets me always is, how do you authenticate the device properly?
Mm-hmm.
The right way to do it is to bury the key in hardware, either with YubiKey or TPM or something like that. But it's rarely deployed in that way. And so, for me, if I was attacking such a system, it would be like, hey, did you really secure that device key well enough? Like, if I own the device, can I lift the key off of it, Or perhaps even an online attack where I own the device and you're online and I ask the TPM to sign something for me or something along those lines, right? So I think that's probably the weakest point, though it is certainly a large step above what people are doing today. And a good friend of ours, Pat Cable over at ThreatStack, kind of nudged us friendly, and he said, look, security is about outrun, outlast. And I think that's what this is here, right? It's like, how can we make this difficult enough that it's really hard, and that's kind of the best we can do. So that device key, I think, is a pretty crucial kind of linchpin in the whole model, and not to mention kind of the security of all of the backend services which are going to be making these authorization decisions. Mm-hmm. Naturally, those are all sensitive systems.
I would imagine any kind of bandwidth starving, like DDoS or something, against the CA would be a very effective attack as well, because if you can't authenticate anything against the other boxes, then you've basically brought down the entire network, internal and external, because everybody's using the same CA. So
absolutely, and this is a big vector that I kind of see in software-defined perimeters is, you can hide the controller behind port knocking, and you can do some things to prevent it from being discovered. But if I can saturate the link, I can saturate the link.
Yep.
So definitely, in fact, I'm actually really pleased that you asked this question, because our very last chapter in our book is called the adversarial view, in which we try to take this approach and say, where is the best place to get in?
Okay.
And there is a section on DDoS and there is a section on identity theft, and absolutely, these things are concerns, and you want to pay special attention to them. However, it should not be thought that, because you have these concerns, this thing must not, it's like, well, we have these concerns, but it's still like a whole lot better than what you see normally today. Yeah.
And to be fair, I mean, this isn't going to be any technology that's going to get rid of DDoSes or anything like that. I mean, can it get rid of DDoSes? Because a lot of them are like DNS amplification. You've got IoT issues. I mean, if you're setting up software-defined network, wouldn't the trust relationship kind of make sure that you're not sending out unauthorized connections to a host that you wouldn't normally touch?
But I'd say on the DDoS front, the nice thing about this model is your intention is captured away from how you implement it. So you can scale out defensive or enforcement systems, right? Or heavily isolate them. Mm-hmm. And because it's all just software configuring that stuff, it's really no more difficult for you as an operator to run a front end for every single service if you want to do that.
Yeah.
It's expensive, but it's doable, and you're getting to leverage all the work you already did. It's not something that you have to blow it up and redo again.
I think you brought up an interesting point too, is that when you talk about DDoS, you have most people think of it as the receiving side, but there's also a sending side.
Yeah.
I think in Zero Trust Network, definitely, as the sender of an attack, you can start to reason about that might just be stopped in its tracks, because if it's not something you'd be normally talking to, there will be policy for it. If there's not policy for it, doesn't get routed. So the sender side is as simple as that. On the receiver side, it's harder to stop the deluge of packets, right? And one of the nice things about Zero Trust is that because you have all this policy codified in a way that can be like calculated, computed, crunched, and distributed throughout the network, you have this opportunity to install kind of like really, really lightweight stateless scrubbers way upstream, which are just looking at basic rule sets that might be calculated from the policy which you have. Right. So we're not talking quite the complexity of perimeter firewalls where you might have like state replication and fault tolerance and stuff like that. We're talking more just kind of like lightweight packet matching. But you have that opportunity to kind of stop them earlier on, though you still have an uplink to that system and so on and so forth. So from internet sources coming in, you still deal with those challenges, but there are some kind of nice tricks and that are opened up as a result of the architecture.
Very cool. Very cool. All right. Well, I guess you just heard it. Doug and Evan are going to solve all the DDoS issues in the world. So I'll get started on that. We're expecting big things in the next month or so. So no pressure. No pressure. So, gentlemen, I've learned a lot. I don't know about Mr. Betcher and Miss Berlin, but this is something that's kind of been weighing on me. I've been trying to learn it because it's coming, especially if you're any kind of startup or emerging company and you're basically in the cloud. So it's I'm very glad you guys came on the show. I'll have to thank Mr. Nick G when I see him next time for suggesting you guys come on the show. Doug, Evan, how would people get a hold of you if they wanted to discuss more about this?
Sure. I mean, for me, you can hit me up on Twitter, just Doug Barth.
Doug Barth, okay.
Doug Barth. I'm on Twitter. LinkedIn, I'm Evan2645, a little more complicated.
Evan2645.
Yeah, but if you hit up like the O'Reilly page for the book, I think our Twitter information is there, and
okay,
should be relatively easy to contact. Yeah. Okay. We're happy to hear from anyone who's interested, honestly. Yeah, so we're pretty nice guys, I think.
If you're looking for potential employees for your
anyone who wants to work on it, let us know, absolutely.
If y'all are needing some VC money, find
do you have any of that?
My daughter's got a piggy bank. I can't.
I don't even have that.
Go ahead.
So if nobody's told you yet, you don't really make a whole lot writing.
Oh yeah. We didn't expect to.
So are you guys going to be talking anywhere? You mentioned you wanted to put this out on the con circuit. Are you going to be doing any development cons? I know DevOps Days was up here in Seattle a few days ago, but you guys going to be at a security conferences or anything?
So right now, like the next one we're definitely speaking at is Velocity in Santa Clara.
Right.
In June.
Yeah.
We put out a few proposals at other like more security focused conferences. So we'll see and find out. Hoping to be at more.
DerbyCon's
on Twitter, and we'll announce when we're speaking. We expect to be accepted in a few more. We don't want to prematurely.
Nice. Well, if you haven't done DerbyCon, they're available until like July 1st. So if you guys want to go to Louisville, Kentucky, people would love to hear this stuff because I'm sure there's not a lot of folks out there doing it, and there'd be plenty of people picking your brain about how to how to operate this in a proper environment.
Yeah, we'd love to speak there and drink some of their bourbon.
Yeah.
You will not have problems finding bourbon there. Yes. All right. So, we tell everybody who comes on the show, but, if you guys ever want to come back on and discuss any other facets of software-defined networking, if you want to do a deep dive into, the hashing algorithms or data flow or, how you would design your ideal network, please feel free to join us because, we love spreading the knowledge of new technologies like this. So that we
awesome.
appreciate
Thank you.
Right on.
Yeah, thanks.
Miss Berlin, you've been very noisy and hardly was able to get a word in edgewise. How would people go about finding you if they wanted to, discuss your own book?
On Twitter.
Oh, yeah?
Yeah.
Okay. And you are at...
InfoSystir, INFOSYSTIR.
Why did that feel?
I forgot because I kind of forgot it.
You kind of forgot it.
Yeah, it's something. Yeah.
It's like pulling teeth, man. Jeez. All right.
Sorry.
That's okay. Mr. Betcher, if people wanted to discuss malware and such with you, how would they go about doing so?
Yeah, hit me up on the Slack channel or at
All right.
VetraPwned on Twitter. I also have a
Slack.
website, log-md.com.
Right on. Ms. Berlin, you mentioned the Slack channel. How would people get a hold of us on the Slack channel if we were doing that? I'm trying to spread out the end.
Yeah,
part
yeah.
here a
I keep
little bit.
because this I keep forgetting too is the sign up. It's what is it? Sign up. Shit, I don't remember now. I have I have it as a link somewhere.
It's
breaksec.signup.team.
oh,
It's in your
there you
favorite.
Is that it?
Yes, breaksec.signup.team. Yes. And
Yes. Sorry, it's late. I'm tired.
it's okay.
Been a
We have
long
a very
day.
vibrant community there.
We
And
do.
Tuesday nights we do our CTF club, which we're working through slowly. Thursday nights we have our Python class with Matt, our instructor. That's going well. And we also are doing our book club on Sunday afternoons with Miss Amanda. She's doing the security, defensive security handbook with people in our book club there.
Yeah, the last one we almost filled up the Google Hangout. I need you to change it to Zoom because
Okay.
we
Yeah.
had like
10 or more people in a hangout and you can't
Yeah.
come on anymore. So the Zoom
Yeah.
does 50. So we should have plenty of people if we do the Zoom. So
it was pretty nice last time.
cool. Well, maybe we can do the Zero Trust Networking book at some point in the future and have
Yeah.
Evan and Doug join us for that. So
Absolutely.
might be something to do. If people are interested in the Zero Trust Networking book, you can find the link at shop.o'Reilly.com, search for Zero Trust Networking, or if you just go to our show notes, there's a link in the show notes. You can find me at Brian Brake on Twitter, BryanBrake. I'm also on Slack quite a bit. As a matter of fact, I moderate that and keep the inmates in line and herd all the cats. And
You do a very good job too.
yeah, I move it to random, people.
Yeah.
So
It's like
How many times have I read that?
all the
well,
time.
you know
really.
what? I have to
And
be the
half
potty.
the time it's my fault.
I have to be the potty pooper. I have to put them in random. So, we're also got a job board. We do the CTF stuff. And our official Twitter is at BrakeSec, BRAKESEC. And that's all I've got. We're everywhere. iTunes, Android, Google Play Store, iHeartRadio, TuneIn Radio app, SoundCloud. There's pretty much nowhere you can't find us. We have a YouTube channel. You can check all the links in our show notes for locations on how to get to that RSS feed. BreakingSecurity.com is our website. So that was it for this week on Breaking Down Security. This show will go out probably the week that I'm at San Security West in San Diego. So if you guys are downloading this and you are in San Diego, please come and see me at the Manchester Grand Hyatt. I will be there doing Sec 504 incident handling with Mr. John Strand. Love to meet you. So please come by the hotel, or if you're attending San Security West, please hook up and we'll come say hello because I'd love to meet you. So that was it for Breaking Down Security this week. Have a great week, and we will talk to you again soon.
Bye-bye.
Bye, everybody.
Thank you.
Thank you.
And we're clear. Oh my goodness, that was an awesome show.
Yeah,
Oh,
it was.
I love
I
that
hope
so
it was
much.
valuable for you guys.
No, that was such good
No,
times,
it's
man.
great.
I love learning that stuff.
Awesome.
And I would just wish that Amanda would shut up and let us ask
You know
questions. I know. I love you, man. I love you, man. I know it's late there. I'm sorry.
It's past my bedtime.
Yeah.
We're really, really excited about it. Obviously, it's a hard topic because there's such little work has been done there.
No, I agree.
And that's what we're looking forward to. Is like, man, let's get some other people on board with this book. Let's get it in front of some people. Let's gain some interest. Let's really kind of try and make this much better.
Well, I worry about people like MSSPs and pen test companies that, they're going to do an engagement or something. They'll be like, oh, yeah, we have, software-defined perimeter, or, we have zero trust networking. And they're going to be like, we can't really cover you Because what does an MSSP do? They put in HIPs, they put in IDS, they monitor HIPs, they monitor IDS. They may monitor net flow at the firewall, but there's no firewall, there's no IDS, there's no IPS.
Yeah.
So unless you're doing it per host, you're screwed.
That's another thing. Like, does that do any of the homegrown zero trust network things log anything?
Yeah, what's the logging like?
Like the logging is actually a really cool story because there are so many authorization checks and authentication checks that occur within a particular flow or request. Every single one of those interactions is something that you can throw off events and logging type stuff for. So you actually get a really, really a great insight into the activity on the network because you have all this rigorous checks going on all the way through the system. And so while you lose this deep packet visibility from some of the stuff that we traditionally see deployed today, you gain all this other visibility, right? And that visibility that you gain is stuff that you can then start to do the behavioral analysis on and all the other.
Have you ever thrown any of that logging into like a log aggregator or SIM or anything to see? I mean,
we like when I was at PagerDuty, we would log all this stuff and we would like watch those relationships churn over and try to correlate them. Usually it was more like correlate them with problems we thought we might be having. But definitely like they do produce some useful data. And I think like, the deployment that we built at Zero Trust, I would say is 15 or 20% of what it could be in terms of the full Zero Trust vision. So there's really a lot more to be done there and a lot of opportunity. And it's just kind of like, not everyone, like there's not really anyone who has done the full scope of the thing. Some people have done this bit. And so a lot of the work in writing the book has been like rallying everyone together in one place. Be like, okay, guys, like, hey, we tried this, what did you try?
All right, so I got one more quick. God, I can't believe I didn't think of this question during the show. All this is going to have to go on after the.
Do you have a
credits.
logging chapter?
Is there a logging chapter?
We don't have a chapter on it, but we do have like a section on like logging and visibility in Zero Trust, and we talk kind of about like the different points in which these things can be hooked, and go into a little bit more detail about it, but it's not like super in depth, right?
Okay, so I have a question. So when a user or a server talks to another server, they authenticate once. Do they have to authenticate again for every connection, or is it just a certain amount of time? How does that work?
I think it depends on your particular, like what you're looking to get out of it, and because Zero Trust is just like, do you adhere to this model? It's not really prescriptive in exactly those kinds of things.
Yeah.
So if it generally is a function of where you place the enforcement. So if the enforcement is placed at network layer, like layer 3 or layer 4, generally it's like connection oriented, so like per TCP flow or per conversation. Mm-hmm. If you place that enforcement up at layer 7, an application layer, like in a load balancer or something, you're talking about literally every application request.
Okay.
So it's a function of what you're looking for, how fast you can do those authorizations, what your performance requirements are.
Yeah.
There's a whole lot of things. That's kind of one of the things about the book is it's very, very loose in some of these things because it really does depend on kind of what your own requirements are and your threat model and that stuff.
Well, the reason I asked was you mentioned the seam, being able to input stuff into Splunk. That's massive amounts of constant connection back and forth. I was just wondering, well, if they're going to have to negotiate every freaking time, you're going to have a lot of bog down. And the other thing I was thinking was, well, with mass amounts of authorizations, are you going to leverage things like with the upcoming TLS 1.3 where they're using 0RTT, where it's like, hey, I've already seen you once. I don't need to re-authenticate you by doing yet another handshake. We'll just do the 2-step handshake and go on through. I was just thinking, because I know Cloudflare and a lot of those are using that because it cuts down the amount of authentications like from 600 milliseconds down to like 4 to 200 seconds. So I was thinking, if you're doing those kinds of mass authentications like that and connections, then that would, using 0RTT in those would behoove you to leverage.
So I think one of the interesting things with if you buy into like say the sidecar model, right, where you make the network security infrastructure concern, mm-hmm. then you can kind of get your cake and eat it too, because you could have this sidecar that's sitting out of process. Ideally, if you do like a containerized application, it's on the other side of the containers, and that thing can do authorization checks before like leveraging some pre-existing network tunnel. Right. And both sides could actually do kind of peered authentication checks. So you can protect yourself a little bit against like one side being owned, while the other side could like, check and make sure that this is still authorized. It's like double work, but it protects like one class of attack.
Okay.
I think like another key realization too is like the separation of authentication and authorization.
Yeah.
So, when you describe like this high round trip overhead that is related to like cryptographic protocols is like a very big problem,
Yeah.
But that conversation there is the authentication of the client. It's not necessarily the authorization, but it is like saying, okay, well, I think you are who you say you are. There's a separate check, which is, okay, now are you allowed to do what you're asking to do?
Yeah.
So you can, those authentication round trips can happen less frequently than the authorization does.
Sure.
So for instance, if you're talking about, like I said, like a layer 7 authorization check, like a HTTP load balancer, right? You might do only one TLS session, but every request that gets fired down that session is separately authorized by the load balancer, right? So you don't necessarily incur like any kind of round trip or communicative overhead. It's more just kind of on the remote end, that authorization process kicking off for every one of those requests you fire down.
Nice. Oh man, I'm so. This is why I always keep recording after this, because this stuff needs to go in the show, because I'm sure there were people asking about the that kind of thing.
Yeah.
So
you just cut and paste that in, or you put that on afterwards?
I'll do it after the music, like I normally do whenever somebody asks interesting questions post show. Like I do. So I'm gonna have all this ready to go before I go to Sands, because I'm gonna be recording a lot of audio, hopefully at Sands Security West. So seriously though, you guys, you should definitely get a hold of like maybe RSA or going to DerbyCon or a B-Sides or something, at least to talk about the last chapter in your book or whatever, at least to be able to, because there will be people there that will poke you and will go, hey, what about attacking this? Or have you thought about this? And it will help make it more robust.
So besides Las Vegas and Visa have both invited us to speak. So we didn't mention them by name because we were submitting this week and like we're still going through approval process. But we were asked to apply, so we hope to speak at besides Las Vegas.
Cool.
And we hope to be kind of hanging around Black Hat. We're hoping to actually have the book printed for that.
Awesome.
But yeah, so we are trying to do that, and we'll check out Derby too, and yeah, please like keep your head up if spread the word, right? Like anyone, like we're happy to chat with.
Sure, absolutely. We'll definitely pimp out the book, and because now hers is out, so we don't have to do as much. So yeah, no, that's awesome.
Keep going. I need all my bills paid.
Them college funds ain't going to pay themselves. Yeah. So all right, well, appreciate it, gentlemen. If you ever, like we said, if you want to hit us up again to come on and talk about maybe you've made some innovations or some changes or something we talked about didn't work and you went another direction, we'd love to have you back on and discuss them. So
yeah, thank you very much for having us.
All right.
What's the future like for the old guard network engineer who doesn't want to innovate and like he's a Cisco firewall Kool-Aid drinker?
I'm sure that shit will be around forever.
Yeah, there's going to be government networks that are not going to do zero network. I mean, there's some that are afraid to go into the cloud.
That's going to shrink like a sun that went nova, right?
I mean, I feel like having come from that background, one of the interesting things is I think that they would be relatively safe. It's the problem will come more in kind of like compliance officers and security engineers who spend a lot of time manipulating firewall configurations and maintaining VPN endpoints and those kinds of things. That will see the most disruption. Yeah. One of the things I like as a network engineer about this architecture is it says, hey, like this is your problem, Mr. System over there. Like this is not my problem. Yeah. I'll shuffle the packets around and you figure your own stuff out. So in some ways, it kind of makes the lives of network administrators easier in that they don't have to maintain all these really beefed up stateful boxes inside the network. Certainly, it opens opportunities for like advanced SDN designs where perhaps an application signals to the SDN fabric that it intends to make a connection and authenticates and is authorized, and then the route is installed. Yeah, is something that we explore a little bit in our book, and we think is very interesting. Very cool. So there is a promising future for those things, but doesn't necessarily preclude the traditional network engineer.
Nice. Yeah, if anything, it's like you get much clearer boundaries than what you might have today in your network. Like Evan and I were just talking about this. Like, so a network engineer today is dealing primarily with packet switching around, but they're also like got a little bit of security enforcement. They have like some visibility enforcement. And this kind of like resets the boundaries so that if you are just really interested in like pushing packets, like it's clear how you can push packets, and the changes you can make in the network are much better like defined. Like obviously, like you think about a VM that Amazon gives you, they still have someone like, you know, setting up physical servers, and if they really like doing that, then they can do it, and they know what guarantees they're giving to downstream clients, and it's in Amazon's case not very many. So
I mean, network engineer is free to renumber an entire section of the data center and know that the policy will be programmatically installed and defined, and I don't have to worry about like any of that stuff that you would normally worry about when you renumber the section of the network. So there's a lot of nice things for network engineers that I find pleasing.
Yeah.
Very cool. I expect Cisco or them to patent some of the protocols and stuff in the very near future.
Yeah, we're expecting Cisco Junipers of the world to to raise some interest. Yeah.
Yep. I can imagine. Yep. All right, gentlemen. Everyone have a good night.
Thank you very much again. Thank you. It's good talking to you guys.
No problem. It was great talking to you too.
Bye.
Later.
Bye-bye.
Bye, guys.